Okay, thank you very much. And I'm going to be presenting on the prospects and challenges of HIV functional cure following treatment of acute HIV infection. This is actually an update on the talk, similar talk that I gave at the same conference about 2 years ago. So I'm very pleased to present some of our latest data on this topic. So obviously we have very effective medicines for the treatment of HIV, but unfortunately these medicines, whereas they are very effective in lowering viral load and improving the quality of life of people living with HIV, they do not cure HIV. And as soon as antiretroviral therapy is interrupted, the virus rebounds and the viral load goes up. And the reasons for this are many, but I've listed some of the reasons that are well known here, including the fact that you have latently infected long-lived CD4 T cells, usually memory CD4 T cells, that can persist in the body for a very, very long time. And as soon as the therapy is interrupted, these cells can be activated and they can start producing virus, which then leads to rebound of the virus. It is also thought that antiretroviral therapy is unable to completely suppress virus replication. So it is thought that there are some cells in peripheral blood or in tissues that continue to have virus
Excuse this technical difficulty. We're connecting back to Professor Thumbi Ndung'u right now.
Are we back on?
Yes, we're back. Thank you. Please proceed.
Okay, so that reason that you have a viral rebound after antiretroviral therapy is interrupted is because of anatomical reservoirs. So it is thought that antiretroviral therapy is unable to penetrate to anatomical reservoirs such as the central nervous system, the digestive tract, and the reproductive tract. And because of this inadequate penetration of antiretroviral therapy to these sanctuary sites, as soon as antiretroviral therapy is interrupted, the virus that is in these sanctuary sites can recede circulation and causing virus to rebound. Now, there have been some studies shown that if you treat people very early during infection and then interrupt treatment, that in fact in a minority of these individuals, in about 15 to 20% of these individuals, the virus does not rebound, or at least there's a delay in viral rebound compared to people who were treated during, or who started treatment during acute HIV infection. So we have been interested in pursuing the question of whether early treatment of acute HIV infection can lead to long-term remission. And we have done this by identifying individuals in what we call acute HIV infection Fiebig stages 1 and 2. This is when antiviral anti-HIV humoral immune responses are undetectable, and the viral load is on an upward trajectory. So this is before peak viremia. So we identify people with the Fiebig stages 1 and 2, and we put them on antiretroviral therapy immediately. And some of the key questions that we are interested in addressing are: what are the characteristics of the transmitted founder virus? What are the immune responses to acute HIV infection in these individuals? And why do these immune responses eventually fail to control virus replication? And what is the impact of the transmitted founder virus on immune responses, as well as on the reservoir and the impact of our treatment on these immune responses? And the ultimate goal of our work is to see whether we can mimic effective immune responses or augment ineffective immune responses in order for us to have a successful HIV vaccine or cure. So the way we have gone about identifying individuals with acute HIV infection, particularly Fiebig stages 1 and 2, is through a cohort that we call the FRESH cohort. And FRESH stands for Females Rising Through Education, Support, and Health. In this cohort, we identify women between the ages of 18 and 23 who are HIV negative. But these women are at very high risk of HIV infection. And we know that they are at high risk of HIV infection because the area in which we work, which is in Durban, in KwaZulu-Natal, in South Africa, we know that the HIV incidence in this age group of women is very, very high. So what we do is we identify women who are sexually active between the ages of 18 and 23, and we provide them with an intensive empowerment curriculum, including pre-exposure prophylaxis, where they come to our clinic twice a week. And when they come into the clinic twice a week, this coincides with the sample collection. So we do a finger prick blood draw that we then take to the laboratory and we test overnight in order to see whether we can detect HIV RNA. And because these women are all HIV negative, when they come into the clinic, the idea is that if they ever became HIV positive, then we are able to identify as soon as they become HIV positive, as soon as they have detectable viremia. And because we are doing this testing twice a week, this means that we can detect them very, very early. And usually when they come into the cohort, we follow them for 9 months with this twice per week HIV RNA testing, and we are able to obtain serial pre-infection as well as post-infection samples, including blood samples, female genital tract samples, as well as lymph nodes. And using these samples, we can study host and viral factors associated with acquisition of disease, but also in those who become HIV positive, we are able to study immunological and genetic as well as virological factors associated with the disease progression. So far, we have identified 76 individuals with acute HIV infection. And this is out of 1,700 enrollees in the cohort. So the incidence in this cohort is very high at 7.9 per 100 person years. So you can see that it is a very high incidence. KwaZulu-Natal is the epicenter of the HIV epidemic globally. The first 14 individuals that we identified with acute HIV infection were not treated because we were following the South African guidelines of treatment at the time, which called for the CD4 counts to fall below 350 cells per microliter before you started treatment. But we subsequently started treating these individuals, and we have treated now the 62 subsequent acute infections that we identified. 76% of the individuals that we identified were in Fiebig stage 1, and they were identified within a median of 4 days since the last HIV RNA test. And in most of these individuals, antiretroviral therapy started within 1 day of detection of viremia. So this is very, very early after detection of HIV infection. So we have already published some of the data, the clinical data on these individuals. So I'm going to rush through this. Basically, what we have shown is that early treatment blunts peak viremia. As you can see here, in the black line is people who are not treated during acute HIV infection, and you can see that their viral load remains very high after acute infection, with a viral load set point that falls somewhere between 10,000 and 100,000 copies per ml. But you can see that when you start treatment immediately, you immediately suppress viremia to undetectable levels. In fact, within 5 weeks or so, everybody has become undetectable. And I should say that when we started treatment in this cohort, initially we were treating with a 3-drug regimen, which is what is used in South Africa as a as a standard treatment. But we also decided that we should intensify treatment with the raltegravir. And so in the red line there, you can see that those are individuals that we now treat with a 3 standard drug regimen plus raltegravir intensification. And the reason for this was that we wanted to see whether we could further lower the viremia and as well as the reservoir in these individuals. Now, combination antiretroviral therapy started in Fiebig stage 1. As I said, blunt peak viremia. And again, you can see here individuals that were treated during Fiebig stage 1. You can see that the untreated individuals have a peak viremia of about 10 million copies. And this is compared to about 10,000 copies per ml of viremia in the individuals that were treated during Fiebig stage 1. Treatment during acute HIV infection also preserves CD4 T cell counts. You can see that the NADA CD4 count, which is the CD4 count within 1 month of HIV infection, is very low in the individuals that were not treated, and that it is significantly higher in the individuals that started treatment during Fiebig stage 1. So, treatment during Fiebig stage 1 not only blunts peak viremia, but actually also preserves CD4 T cell counts, which we think is important for cure strategies later on in these individuals because we are preserving the immune system. What we have also shown and have also published is that when you start treatment during Fiebig stage 1, you pretty much prevent seroconversion in the majority of these individuals. So the first 14 individuals that you see on this graph all became Western blot positive, and that is represented by the red dots that you see in the lines that represent the various times that we tested for seroconversion. Whereas the subsequent individuals that we identified with acute HIV infection remain mostly Western blot negative, as shown by these blue dots here over time, even after about 1 year of infection. So normally in HIV infection, you would expect everybody to have seroconverted within a month or 2 of infection. But these individuals, even when we check them out at around 1 year post-infection, most of them are in fact still Western blot negative. And this means that these individuals have to be really counseled and informed about their status, because some of them may inadvertently believe that they're HIV negative, whereas in fact we know that they are HIV positive because they are suddenly RNA and the nucleic acid positive. It's only that they do not seroconvert because we are introducing antiretroviral treatment very, very early. So we have also been looking at to see whether these individuals make cellular immune responses, specifically HIV-specific CD8 T cell immune responses. And overall, what we found is that the majority of individuals make cytotoxic T cell immune responses, despite the fact that they do not seroconvert. So you'll see there that by interferon gamma ELISpot, which is the standard assay that you use to detect HIV-specific CD8 T cell immune responses, that the majority of these individuals, in fact, make interferon gamma ELISpot responses. And the same is true when you use tetramer staining as well as CFSC proliferation to look for HIV-specific CD8 T cell response. Interestingly, although they make these CD8 T cell immune responses, these immune responses are of a lower magnitude compared to untreated individuals. And that's perhaps not very surprising, because the untreated individuals have a lot of antigen circulating, whereas the treated individuals have much lower antigen. But despite the fact that these individuals are making much lower magnitude immune responses, these immune responses seem to be much more functional. And this is shown on the panel on the right, where you can see that when we look at the percentage of cells that are interferon gamma positive, you see that among the treated individuals, they have much higher amount of interferon gamma positive HIV-specific CD8 T cells compared to the untreated individuals. So we know that during acute HIV infections, the CD8 T cells are defective and are not normally able to make interferon gamma interferon gamma responses. But in fact, what seems to happen in these individuals is that you rescue the ability of these CD8 T cells to produce interferon gamma. The next slide shows HIV-specific CD4 T cells, and what we have done is to look for the ability of these individuals that were treated early to make HIV-specific CD4 T cells, and the ability of these CD4 T cells to proliferate. And what we are able to show again is that if you treat individuals during Fiebig stage 1, you rescue the ability of CD4-specific, HIV-specific CD4 T cells to proliferate, and this is a function that can actually last for a long time. So you can see here that even after 250 days, they're still able to proliferate, whereas in the individuals that are not treated, you have much lower magnitude of a CD4 specific response, and in fact, by about 1 year post-infection, all HIV-specific CD4 T cells have in fact disappeared, and you are not able to detect them during, as the infection progresses. So overall, what we see is that early antiretroviral treatment preserves the proliferation of HIV-specific CD4 T cells, which we think that might be important later on when we try to intervene with curative strategies in these individuals, because we may be able to prime and boost these HIV-specific CD4 T cell responses. Okay, the other thing that we have been interested in this cohort is to look at the nature of the transmitted founder viruses. And specifically, what we have been interested in is the ability of broadly neutralizing monoclonal antibodies to neutralize transmitted founder viruses in this cohort. And what I show you here is the different epitopes that are targeted by broadly neutralizing antibodies. So we have the C3v3 glycan-dependent broadly neutralizing monoclonal antibodies. We have a CD4 binding site epitope that is targeted by different monoclonal antibodies. And we have the MPR region, which is also another epitope that is targeted by broadly neutralizing antibodies. The V1, V2 glycan region, as well as the GP120, GP41 interface. And shown here are then in red and blue are the various broadly neutralizing monoclonal antibodies that have been isolated in the field that are able to target these different epitopes. And in blue are some of the broadly neutralizing monoclonal antibodies that we had in our possession that we wanted to see whether they could neutralize some of these transmitted founder viruses. In the next slide, I show you that we have also sequenced the envelope glycoprotein in these individuals. And basically what we see is that in the majority of them, it's only a single transmitted founder virus that is transmitted, and that is shown by the fact that in these phylogenetic trees, you can see that all the sequences, all the virus sequences that we have been able to sequence from one individual patient, for example, this patient 093, are completely identical. There are a few cases, for example, this patient 271, where we have two lineages of viruses that infected this particular individual. And so what we have done is to clone some of these viral envelope glycoproteins and then test them for the ability of broadly neutralizing antibodies to neutralize these transmitted founder viruses. And here are some of the data that we have been able to obtain. And what we see is that some of these antibodies are very effective against transmitted founder virus, but actually no single broadly neutralizing antibody neutralizes all the transmitted founder viruses. So you can see that, for example, if I give an example of this particular monoclonal antibody, VRC01, which is a monoclonal antibody that is already in clinical trials in South Africa, you can see that there are many viruses that it does not neutralize, compared to something like PGT121, which does very well in neutralizing most of the transmitted founder viruses. So overall, we find that there's no single broadly neutralizing antibody that neutralizes all the transmitted founder viruses. However, some of the antibodies, such as PGT151, PGT121, PGDM1400, and CAP256, show very good coverage. And interestingly, the patient that had two different viruses that infected them, appears to have one virus that is neutralized sensitive, for example, to this monoclonal antibody PGDM1400, and then you have another clone from the same patient that is completely resistant to this monoclonal antibody. And this basically, this data underlines the fact that using just one broadly neutralizing monoclonal antibody may not be enough in order to achieve the neutralization and in order to achieve antiviral effect in these individuals. And the next slide here also nicely illustrates that point. This is a study from Dan Barut's laboratory, and it shows the ability of single broadly neutralizing antibodies to neutralize various viruses. In this case, PGDM1400 and PGT121, broadly neutralizing monoclonal antibodies. And you can see here in red that these broadly neutralizing antibodies neutralize a lot of viruses, but they also miss a lot of viruses, shown here in blue. And the same applies to this other monoclonal antibody PGT121. However, when you combine the two NAbs, you see that now you get much better coverage, and they actually miss only a very few only a few viruses. So we think that going forward, using a combination of broadly neutralizing antibodies is probably going to be the best strategy if you're going to use broadly neutralizing antibodies in order to achieve antiviral effect in this individual. Okay, I just wanted to quickly talk about the reservoir measurements in this cohort, where we have also looked at the reservoir, and basically what we find is that early treatment blunts peak viremia, as I already showed you earlier, but interestingly, it does not blunt total cellular DNA, and we think that this means that during acute HIV infection, treatment has a profound impact on viral load, but it doesn't have much of an impact on cellular total DNA because the reservoir is established very early, and by the time we start treatment, the reservoir is already actually established, and it's very difficult to further reduce the reservoir in this individual. However, treatment does lead to the decay of total DNA, and you can see here that in these individuals that were treated during acute HIV infection, that there is a steady, even though it's a very slow decline of the total DNA reservoir, and this is compared to the individuals that were not treated. So early treatment does have its benefits, including lowering the reservoir, even though it does not affect the peak DNA load. And this next slide also shows that early treatment has a much more profound impact in terms of suppression of viral load. As you can see, there is a magnitude of logs of suppression of viremia, but it has a very modest impact on the DNA. So the reservoir itself is not really much affected by early treatment compared to what early treatment is doing to viremia. We have also been interested in looking at persistence of HIV in lymph node samples. And I'm going to show you here with an example from one individual that we treated during acute HIV infection. You can see that this person becomes completely suppressed in terms of the viral load, and they have very good CD4 cell counts. And when we do an excision of the lymph node after about 1.5 years of infection, what we actually see is that we can very readily detect P24 within the lymph node compartment. And not only can we detect P24, but we can also detect by RNA scope HIV RNA within the lymph node compartment. And so we think that what this means is that there is persistence of virus. And in fact, we have some evidence that there might be ongoing virus replication within the lymph node compartment, despite the fact you have complete suppression of viremia in peripheral blood. Now, one of the things we have been interested in this cohort, in this cohort, is to see whether we can interrupt treatment. And our original hypothesis was that because we were treating these individuals very, very early during acute HIV infection, that if you interrupt treatment, you might actually be able to have remission in some of the individuals. But unfortunately, there was this study published from Thailand in another cohort where individuals were treated during acute HIV infection during Fiebig stage 1, and what they showed is that in about 9 individuals that were treated, and then treatment was interrupted after about 3 years. In all of these individuals, there was a viral rebound within a very short period of time, within a few weeks after treatment interruption. So we actually don't think that it is going to be a prudent idea to just interrupt treatment without some other kind of intervention in this cohort, despite the fact that we started treatment very, very early. So we are proposing to do a study where we use broadly neutralizing antibodies for therapy and functional cure in this cohort. And the rationale behind this is that several broadly neutralizing antibodies have been shown to prevent infection in macaques and to suppress viremia in HIV-infected persons. And it's been shown that broadly neutralizing antibodies can also suppress viral rebound during antiretroviral therapy interruption. It's also been shown that therapy with a broadly neutralizing antibody elicits host immune responses against both HIV and HIV in animal models. And broadly neutralizing antibodies used in protection studies have also been shown to clear HIV in distal sites. So in our study, we are proposing to use both broadly neutralizing monoclonal antibodies, but also toll-like receptor agonists, because toll-like receptor agonists have been shown to play an immunomodulatory role. So, for example, toll-like receptor agonists such as TLR7 and TLR9 agonists activate innate and adaptive immune responses, but also they have the ability to activate innate immune responses. They have also been shown to induce viremia, so they have a latency reversal properties that we think we can take advantage of. And it's also been shown in a study published last year that a combination of broadly neutralizing antibodies and toll-like receptor agonists can result in long-term control remission in non-human primates. So what we are proposing to do is to use a combination approach where we use a latency reversal agent, such as a toll-like receptor agonist, to reverse latency. And we think that this can also penetrate into some of the reservoir sites, such as lymph nodes. And this will also activate innate and adaptive immune cells. And we think that this combination of broadly neutralizing antibodies with toll-like receptor agonists could lead to long-term remission. And of course, we're also proposing to use broadly neutralizing antibodies in addition to the toll-like receptor agonists. And the rationale here, again, as I said, is that NAbs have direct antiviral activity because they will inhibit infection of new cells. But it's also been shown that broadly neutralizing antibodies can form complexes with viral particles that are reactivating from the reservoirs, and that this can be picked up by cytotoxic, by dendritic cells and presented to cytotoxic T cells, leading to the generation of new immune responses. And therefore, basically, with NAbs, you not only have a direct antiviral activity, but you can also prime new immune responses in individuals to whom you give these broadly neutralizing antibodies. And these new immune responses can lead to long-term remission. So I'm going to go very quickly now and finish and say that we are proposing to do an intervention study in the first cohort with 24 individuals. Again, we are proposing to use females that have been treated during acute HIV infection in this particular cohort that have been treated for a long time and have had either virus suppressed, or alternatively, we can use individuals with acute HIV infection and give them a combination of broadly neutralizing monoclonal antibodies and toll-like receptor agonists as latency reversal agents, and then see what happens. And in this slide, I've just listed some of the considerations for the selection of the agents that we are going to use. Again, it's broadly neutralizing monoclonal antibodies and an immunomodulatory agent. So a combination of either dual or triple combination of broadly neutralizing antibodies with a toll-like receptor agonist. And these are some of the agents that we have chosen to use in our study. So we are going to use an antibody called GS9722 that targets the V1, V3, V2, and VRC7, another very effective broadly neutralizing antibody. And we are also going to use the toll-like receptor agonist as as an immunomodulatory agent and a latency reversal agent. And the primary objectives of the study we are proposing will be to assess the safety, tolerability, and pharmacokinetics of this combination of antibodies with a toll-like receptor agonist. And then we propose that we will interrupt treatment after giving these doses of the NAbs and the toll-like receptor agonist to see whether this affects the time to viral rebound and the magnitude of peak viremia after treatment interruption. And we also have a number of other exploratory objectives. So I'm just going to go quickly to, I'm going to skip this slide to say that really what we'll be testing in this clinical trial is to see whether a combination interventions where we have treated individuals during acute HIV infection and therefore they have a low reservoir, they have preserved immune function, and then we will intervene with adjuvants and toll-like receptor agonist, in this case toll-like receptor 7 agonist, and then we intend to do sanctuary disruption and immunomodulation with a broadly neutralizing antibodies, and our hope that this might lead to long-term remission in these individuals that were treated during acute HIV infection. So in conclusion, we think that acute HIV infections offer new insights into the characteristics of the transmitted founder virus, the nature of the immune responses and reservoir establishment, and this provides essential information for vaccine and functional cure strategies. We think that study participants initiated on antiretroviral treatment have diminished magnitude of humoral and CTL immune responses, and in the fresh cohort, the reservoir is established very early, and even in Fiebig stage 1 treated individuals, the total DNA reservoir during acute infection is similar to untreated participants with persistence in lymphoid tissues, and early treatment leads to slow but steady decay of the reservoir, which may indicate that it may be easier to cure these individuals, although that needs to be tested. And like I said, we are proposing to use a combination of approaches, including early treatment plus immune modulators plus specific antiviral agents, in this case, broadly neutralizing antibodies, to see whether we can achieve long-term remission in this cohort. And finally, I just wanted to acknowledge the study participants and my co-workers. There are a lot of them. I can't name all of them, but also our funding agencies who have really supported this cohort over the last 5 years. Thank you very much.
Thank you, Professor Ndung'u. That was a very informative presentation. In the interest of times, I'm going to restrict just one question, and I would urge you perhaps to go to the chat line if you have time and maybe answer some of the others. And again, I want to thank you very much. I know you got up at something like 6 a.m. this morning, your local time. So the question that I have is, we heard a talk earlier this morning about a mutant virus in the envelope protein A539V, and I wondered whether these broadly neutralizing antibodies that you've mentioned and discussed, some in particular, whether any of these are effective against these ARV-resistant strains.
Against ARV-resistant strains?
Yes, correct. So you mentioned that these broadly neutralizing against the founder virus have application against many of the other subsequent viruses. I wonder whether you've examined them against any of the ARV-resistant strains.
Yes, so we have actually examined them against some of the ARV-resistant strains, and these broadly neutralizing antibodies, in fact, have activity against some of the ARV-resistant strains. I have to emphasize that the reason that we are doing some of the screening of the transmitted founder virus is actually to see which of the broadly neutralizing antibodies are likely to have them the most effective, to be the most potent against these transmitted founder viruses, because as it turns out, and as I showed, the activity is not uniform. So there are some that are very potent against transmitted founder viruses, and there are some that are not. But the good news is that there are also some that are very potent against drug-resistant viruses. And so these broadly neutralizing antibodies could be an additional antiviral strategy in individuals that are infected with drug-resistant viruses.
Thank you very much. With that, let me thank you again from all of us here. Thank you so much.